Right, good morning class. So at this point we were busy with exercise 2.11. That's on page 42. We were using the quadratic formula. Is that correct? Right. Any issues there? Did you have to do the whole exercise? Okay. Any issues there? 11 and 12. 11 and 13. Okay, I'll do both. I will do 11 and 13, okay? Because the same idea is tested in 12 and 13, okay? It's just a matter of factorization there. So this is exercise 2.11 number. This is on page, page 42. Okay. So number 11, firstly, we're going to need to find the LCM. What's my LCM here? X minus 1. What's my restriction? X can never be equal to? So 3x is over 1, 2 is over 1. We will multiply the first fraction by x minus 1. What we left with? Okay, or we ask ourselves, what must x minus 1 be multiplied by to get x minus 1? By 1. So that's also by 1. So it's 1 times 1 minus 3x. What must 1 be multiplied by? X minus 1. Not so. It must be multiplied by x minus 1. So 3x must also be multiplied by x minus 1. What must that 1 be multiplied by to get the LCM? X minus 1. So it's 2 into x minus 1. So from here it's a matter of simplifying. There's going to be 1. 1 times 1 is 1. Negative 3x times x is negative 3x squared. Negative 3x times 1 is positive 3x. 2 times x is 2x, 2 times negative 1 is negative 2. Since it's quadratic, we take everything to one side with 0 on the other side, so it becomes positive 3x squared. I'm writing it one time in standard form of ax squared plus bx plus c. I'm writing it in that form. Why? So that I can substitute it in my quadratic formula. So we got 2x minus 3x. What's 2 minus 3? Negative 1. So 2x minus 3x is negative x. Negative 2 minus 1 is negative 3. So in terms of my formula, or in standard formula, therefore, A is equal to 3, B is equal to negative 1, and C is negative 3. You guys understand? What's my quadratic formula? X is equal to minus B plus minus the square root of b squared minus 4ac over 2a. Not so? So, once we do the substitution, x is equal to minus 1 plus minus the square root of negative 1 squared minus 4. My a value is 3, my b value is negative 3, and that is all over 2 times 3. Okay? So, from here, this is a matter of simplifying. The question says to 2 decimal places. Correct? Yes, I'm going to press SD, standard decimal. So it's negative 1, so I can just write 1, plus the square root of negative 1 squared, which is 1, minus 4 times 3 times negative 3 over 2 times 3, which is 6. That gives you an answer of 1,18. Otherwise, we change that plus to minus, and we get negative 0,84. Okay? And the nice thing about this is we can test it, if it works. Remember the last, if I press answer, that's the last answer calculated. I can test for any one of the two. If one works, the other definitely works. So it's 1 over the answer, which is x, minus 1, minus 3 times x. What should the answer be? 2. There we go. Okay. Yes, Michael. Negative. You are absolutely correct. Negative 0.85. Thank you. Otherwise, you would have lost the mark, no? You're not rounding off properly. Right. And then let's look at the next one quickly. The 13. Okay, so yeah, you need to factorize my trinomials first, my denominators first. So it's going to give you 1 over, that is x plus 2, x minus 1. Okay, minus. Now if you look at 2 over x minus x squared. First I'm going to swap that around. There's a negative there. So it's going to become positive. Okay, so it's x squared minus x. What factorization now can take place? Common factor x. Otherwise, if you want to write it out and not do it on the side as I did it, no problem. It will just take you an extra step. Okay. What is my LCM here? What's the LCM? 2x into x plus 2, x minus 1. I've accounted for the first denominator, the second denominator, the x and the x minus 1, yes, and the 2x. What's my restriction here? X can never be equal to 0 in that case. X can never be equal to minus 2, as well as x can never be equal to 1. Okay. So we ask ourselves, okay, what must the first denominator be multiplied by to get the LCM? 2x, that's 1 into 2x. What must the second denominator be multiplied to get the LCM? 2 into x plus 2. So that 2 times this 2 is going to give you 4 into x plus 2. 2x must be multiplied by what to get x plus 2? The LCM, sorry. X plus 2, x minus 1. You will agree with that? So you get rid of the brackets here. So that's going to simply give us 2x plus 4x plus 8 equals, that is exactly the same as that way, which is x squared plus x minus 2. Trinomial, so 0 is equal to x squared. X minus 2x is minus x, minus 4x is minus 5x. Minus 2 minus 8 is minus 10. So what's my a value? What is the a value? 1. The b value? Negative 5. The c value? Negative 10. What's the quadratic formula? X is equal to minus b plus minus the square root of b squared minus 4ac over 2a. Not so. So therefore x is equal to minus b. B is negative 5. Okay? So it's going to be minus 5 plus minus negative 5 squared minus 4. Your a value is 1. Your c value is negative 10 over 2, and your a value is 1. This now implies that x is equal to, or x equal to. So let's punch it in. You've got the negative, open brackets, you've got negative 5, close brackets, plus the square root of negative 5 squared minus 4 times 8, which is 1, times c, which is negative 10, over 2 times 1. It's going to give you 6,53. Is that correct? Huh? 6,53. And the other one is? The one dealing with the negative. It's going to be negative 1,5. Okay. The person who asked with regards to 12, do you pick up your mistake? Who asked 12? You pick up your mistake. Who asked for 13? Right. Where did you go wrong? Four. Yes? Yeah?
Yeah. I then 4. Afterwards,
2
times x.
Oh, I see. Okay, so you add 2 here, not 2x. But the x is accounted for. You couldn't have gone with x there. Okay, on that side, what is your mistake?
In the bracket with the x plus 2.
Which line?
Line.
This one here?
No.
No, this one?
Yes.
Yes, okay.
So then where it's 1 is there 2.
You put a 2 here.
No, sir, on the other side.
Which side? Here?
The right-hand side.
The right hand side. Yes?
So I've got an x squared minus x, not plus x.
Oh, your mistake is here. When you multiply that. Okay. Any other confusion? No? Okay. For homework, we did the whole 2.11, eh? Alright. Normally what I do is, for the nature of roots quadratic equations, what I do is I give you a chance to do this in class, 2.12. But since we don't have time now, much time, your 2.12 is homework. We're going to discuss this on Monday. Very, very important to understand or to complete this table. We're going to discuss what the difference of these categories are, the nature of roots and things like that. It's going to come from this discussion. Okay? So if you're not going to do it on the homework, you won't understand what we're talking about on Monday. So please do that. Exercise 2.12, we do that whole exercise there. That whole table there. 2.13 filters from 2.12. You need to do the understanding of 2.12 to do 2.13. Your next heading is simultaneous equations. I'm reading on page 45, okay? Okay, now, simultaneous equations, we have dealt with this before, not so? Last year you have dealt with simultaneous equations and you wrote the exam on this as well. No, it was in quite a few papers after it was introduced, okay? So let's read what they got in grade 11. In grade 11, we are told that solving equations simultaneously requires finding values of the variables that satisfy all the equations at the same time. Simultaneous means to say things at the same time, doing things at the same time. This chapter will deal with simultaneous equations where one equation is linear and the other one is quadratic. Okay? A linear equation is an equation where the highest power of the variable is 1, and the quadratic equation is an equation where the highest power of the variable is 2. Okay, we know that. Simultaneous equations graphically. We've done this last year. Not so? When we drew the graphs, and we looked on the graph where the graphs are intersecting, not so? And we can read that points of the graph. Then we do it calculations to confirm that point, not so? So that is dealing with this exercise here. I'm not going to do this exercise, okay? Because as you know, I'm taking it slow because of the recordings we are making. So some of these things are unnecessary. Not unnecessary, but it's repetitive of what we did last year. Okay? And under normal circumstances, I don't teach it anyway. Okay? We're looking at example 1 on simultaneous equations, and this is on page 49. Okay. So write that down, Salam. Just see something before we abandon that completely. We will look at the graphical representation of which is exercise 2.14 again when we do graphs. Okay, I will highlight that again when we do graphs. Okay. So exercise example 1, and this is on page we said 49. The question says solve the following equations simultaneously. Simultaneously means at the same time. The first equation is y minus x is equal to 2 and x squared plus xy minus y squared minus 4. And that's equation 2. Alright, so what's the first thing we need to do? Normally this is not given. Okay, I think I must just recut this here. This is normally not given here. Labeling the equations is normally not given. Okay, so let's recut. Whoops. Okay. That look ugly, no? But okay. Yes. Oh, it's frozen. Sorry about that. So solve the equations simultaneously. We've got y minus x is equal to 2 and x squared plus xy equals y squared minus 4. So what is the first thing we do? We label the equations. That's the first step we're going to do. Make a note there. Firstly, we're going to label the equations. Name the equation 1 and equation 2. Alright, here's equation 1. Is first, and equation 2, of course, in our set. Alright. The second point is from the linear equation, make either x or y the subject of the formula. Make either x or y the subject of the formula. Okay. So which equation is linear? The equation 1 or equation 2? Equation 1. So you say here from equation 1. What are we going to make the subject of the formula, x or y? Why are we not going to go with x in this case? It's negative. Otherwise, you must still divide by negative 1. Not so. So we're going to take the x over. And what is this equation now? Y is equal to x plus 2. And you label that equation. So then the note is going to read, from the linear equation, make either x or y the subject of the equation, and label it equation 3. What do we do thereafter? Substitute, yes, as we did last year, we substitute equation 3 into the other equation that we haven't worked with. In this case, it's equation 2. So you note there, substitute equation 3 into the other equation we haven't worked with. Okay. So by doing that, what is going to read now? So wherever I see a y, I'm going to replace it with x plus 2. There's going to go x plus 2 and there's going to be x plus 2. So in other words, it's going to be x squared plus x into x plus 2 plus x plus 2 squared minus 4. Again, wherever we see a y, we are going to now replace it with x plus 2. So do that step quickly. You simplify it for me. Alright, so what do we get? Why did none of you stay for the maths class yesterday? I felt so bad, I felt lonely. Sports. The sports is keeping you away from maths. No, my girl, that's not right. Right. So what do we get? X squared plus x squared plus 2x equals x squared, x times 2 times 2 is 4x plus 4 minus 4. You all got that? So what is this to us now? Trinomial. Not so? So that cancels that, that cancels. So in other words, I got x squared, 2x minus 4x minus 2x equals. You all got that? Any confusion? Not yet. Nice. Now what? Common factor of x. What are we left with? X minus 2 equals. Therefore, x equal to 0 or? Have I done the job? No. What do they still want? y. So I substitute that back into equation 3. Both. So we go with the first one. You will have y is equal to 0. Remember x is now 0. X plus 0 plus 2, which is 2. So if x is 0, y is 2. On the other hand, we have y is equal to x is now what in this case? 2. And 2 plus 2 is 4. So if x is 2, y is 4. Okay? Any confusion? Let's do one more before the bell rings, okay? Yes? 2x and 2y. You can test it also to see if you're correct. Let me show you. No? I think we tested last year already, but let me show you again. Okay, let's use a different color. We haven't used blue. Okay. Let's see here. Remember what is x? Is 0 while y is 2. So we can only use those two together. So, if you got 2 minus 0, what's 2 minus 0? 2. So that one works. Okay. Now you say, okay, but that's the easy one. Let's go to the other one. That is 0 squared. 0 times 2. 2 squared. Right. So there's going to be 0 squared plus 0 times 2. So the left hand side is 0. Not so. What is 2 squared? 4. 4 minus 4 is also 0. So it works. Otherwise you do the same for I want to scare you that. That's grade 12 geometry. Very nice topic if you know your grade 11 geometry. Okay.
So geometry.
Like go. Don't even say that. It's easiest. Right. Then, listen. If you had known your grade 8 geometry, do you know your grade 8 geometry? You know your grade 9 geometry. You know it well. And you won't have a problem with grade 11 geometry. Grade 10 just deals mainly with quads.
So it's like these that also I see.
Okay, now you come speak to me, break. Why are you taking over our period now? Okay. Okay, I'm also just saying. Right. Let's go with the second one quickly. X is 2, so 2 squared. 2 times 4. So 2 times 4 is 8, plus 4 is 12. On this side, we got 4 squared. 16 minus 4, 12. So that works. You understand? We're coming Monday, first break or second break, Michael? And we can talk about it. First break. Nice, I'll be here. No? I'll wait for you. People be on page. No. I pray second break. Huh? 49, page 49. Sample 2, page 49. Right. Solve the following equations simultaneously. We have y is equal to 2x minus 1 and we've got x y is equal to 10. So what do we do first? Sorry? Label. So this label, this is going to be 1 and 2. What's the second step we do? What's the second bullet we go in? Sorry? Make the linear equation. The y is. Do we have an equation like that? Yes. So do I have to make x the subject of the formula in equation 1? No. Must you make x the subject of the formula in equation 2? No. So that step is already adhered to. Not so? Incorporated already. What's the next thing we need to do? Substitute. Here we're going to do. We're going to substitute equation 1, which is already the subject of the formula, as y being the subject of the formula, into equation 2. So do that quickly, and you must simplify. So what do we get? You're going to get, wherever we see a y, we put 2x minus 1. So it's x into 2x minus 1 equals 10. Here you're supposed to have said, substitute equation 1 into equation 2. You all agree with that? No?
Yes, sir.
Nice. Okay. So what do we do now? Multiply this one. Right. Is multiply? What do we get? 2x squared minus x minus 10 is equal to 0. So many of you are going to go now with quadratic formula. You can't factorize it right now. However, I think I can factorize this one. Let's see.
You can, sir.
Yeah, okay, nice. There's 1 and 2, for 10 is 1 and 10, 2 and 5. Do you add or subtract? Subtract. 2 times 2 is 4. 5. 4 minus 5 is 1. And that's what I want. 1 and a 2 and 2 and a 5. Can you see? Factorizing is easier. Or not easier? Quicker. But that is if you understand the rules. Not so. However, if you don't understand the rules, then use a quadratic formula. No? Don't let anybody tell you otherwise. That you're not going to get all your marks. You will get it. Don't worry. Okay. So what do we have here? X and x. Not so. What about our signs? Plus and minus. A bigger product must be negative. So that's going to give you 5x. That's going to give you 4x. You all should agree that 5 is greater than 4. So the 5 must be minus and this is plus. Can you see that, people? So what do we say? X plus 2 is equal to 0, or 2x minus 5 is equal to 0. So x is equal to negative 2, or x equal to? Have I done the job? No. Not complete. So what happens is I must substitute back into that equation. Why do you think I won't go into the second equation? It won't be wrong, but why not? Because in the first equation we already have y as the subject of the formula. Can you see that, people? So let's do that. So we say y is equal to 2 times, what's my x value? Negative 2 minus 1, which is negative 4 minus 1 is negative 5. On the side we have y is equal to 2 times 5 over 2 minus 1, which is 4.
So, sir,
Yes.
if we use
Yes, if he's going to equation 2, and then it's going to be, it has much x, y is equal to 10. So you got negative 2, y is equal to 10 divided by negative 2 is negative 4. Which is the same answer. Otherwise, x, y is equal to 10. If y is 5 over 2, so 5 over 2, y is equal to 10. Y is equal to 10 times 2 divided by 5 is 4. You understand? So 100% you would have gotten it right. But just substitute it where you already have y as a subject of the formula. It makes things easier. Not so? You see, they have written how many more steps. Okay, the same number. But they're now working with, I must still divide and all those things. Okay. And again, we can test it. We got x times y. Negative 2 times negative 5 is 10. 5 over 2 times 4 is also 10. And yes, it works. Okay, it's derived from this equation. That's why that one will always be there. Okay, just test it on the other one that wasn't used in solving, in pursuit of solving for y in that second, in that green section. People, any questions? Any problems? No. Okay, you're shaking your head now, no? Come Monday, it's a different story. People, example 3 definitely will do on Monday, but homework is 2.15. You do numbers 1 to 6. Questions 1 to 6. If you have a problem with this, send me a message. No? No. Yeah, over the weekend anytime. I won't normally reply immediately. But if you have a problem, I've made a video on this already. Okay, a short video. Not as these ones are, but it has a stand and whatever. It's done from a cell phone. The quality is not that great, but if you have a problem, let me know. I can send you that. I've done all the odd numbers already of this exercise. Okay. Otherwise, you sorted for the weekend. You need more sums.
No, thank you.
You could have just said yes for the video, like. It looks like I'm working with people that wants to work, when you understand. But now they know now it's people that don't want to work. But anyway, right, you pack up, enjoy the weekend.